So far we've been finding antiderivatives that we're able to either use a simple power rule to find, or we're able to recognize the function that we take the derivative of to get what is in the integrand. Finding the antiderivative is the same thing as evaluating an indefinite integral. An indefinite integral does not have bounds on the integrand sign. So when we have a problem like this, we can go term by term, and we can get rid of the integral by adding 1 to the power, x cubed, and then divide by that new power. We go to the next term and we can find the antiderivative of sine, just recognizing that if we took the derivative of cosine, we would get negative sine. So that means we need a negative on the cosine, and then we have our plus c. If I take the derivative of this expression right here, then I should get x squared minus sine x. Let's do that really quickly. If I were taking the derivative of this term, I would bring the 3 down in front. It would cancel with this 3 right here, and I would subtract 1 from the power. If I take the derivative of cosine, I get negative sine. And if I take the derivative of the constant, I get 0. So you can see that this matches the integrand on our indefinite integral right there. But what we want to do is be able to find antiderivatives that are not as simple as that, like this one. What makes this one different is that we have a product here of sine x and e to the cosine x. So a couple of differences. First of all, it's a product, and there is no product rule for the indefinite integral. There are several methods for finding antiderivatives or evaluating indefinite integrals, and we're only going to use about 3 of the most basic methods other than recognition. So the thing that we're going to do is use a u substitution. Using substitution does not always work, so this is something that you try. If it doesn't work, then you have to find another method. So let's just walk through the problem and I'll explain as you go. What you want to do is choose a value for u, or choose a part of your integrand right here to be a u, so that if you substitute the u in there, then it makes it an easier integrand to find the antiderivative of. Key places to look are exponents or denominators or under the radical, things like that. So I'm going to let my u be cosine x. Now the next piece I need is differential u. If I take the derivative of u with respect to x, differential and derivative mean the same thing, then I'm taking the derivative of cosine, which is negative sine x. Now I don't want du dx as a fraction, so I'm going to multiply both sides by dx. That separates my differential u and my differential x, and that's what I want. Because I want to substitute, I want to find this in my integrand over here. And I want to take it out of there so that I can substitute a du. I'm trying to simplify this expression. Notice that every letter in the integrand here, including the tail, has the same letter. It's all in terms of x. So when I rewrite this in terms of u, it has to be entirely in terms of u. I can't mix the x's and the u's. So I find my u, I find the derivative of u, and I'm looking for all of this stuff up here. Here's a sine x and a dx. Now the thing that's missing is the negative. If there's only a constant missing, then you can fix it. I can put a negative in front of the sine x as long as I also multiply by negative. And the fix we usually put outside the integrand. If you multiply negative 1 times negative 1, you get positive 1. So the value of the expression has not changed. But now I can use this negative with the sine x and the dx and substitute du for all of that. That leaves the e, which has not been substituted for, and the cosine x, which I'm calling u. So e to the u du. The negative that I put out front is still out front. Now this is something that I can look at and tell what the antiderivative is. If I integrate e to the u, then I get e to the u. And then since this is an indefinite integral, I get c. If our problem started out in terms of x, then our answer needs to be in terms of x. So we're going to take this expression for u and substitute it back in right there. So I get negative e to the cosine x plus c. Now just like our previous example, this is the antiderivative, so if I take the derivative of it, I should get the integrand that I started with. So let's make sure that that happens. If I take the derivative of negative e to the cosine x plus c, then I'm going to have negative e to the cosine x, and then chain rule says then multiply by the derivative of cosine x, which is negative sine x, and then the derivative of the constant is 0. This negative times this negative becomes a positive, and if I simplify this, I can write the sine x first times e to the cosine x, and that's exactly what my integrand was. That's an easy U substitution. The next video will show you another example.